This video is to accompany the data-driven habitat suitability maps or habitat association maps produced by COVNOD and WWBIC for the Bionet Local Nature Partnership. My name is Youssef Samari. I'm the GIS officer for WWBIC. We're the Local Environmental Record Centre or LERC for the West Wales region. All 4 LERCs in Wales work together as part of the LERC Wales Consortium. I created the maps in close consultation with COVNOD, the North Wales LERC, and input from members of the Bionet LNP. This video will give a brief overview of the maps, including how they were made and how to interpret them. This map is one of the outputs of this project. It's a habitat association map of the Bionet region for Adder. In a nutshell, it's a phase 1 habitat map with each habitat type color-coded based on its association with adder records across the whole Bionet region. We created these maps for the following 4 species: adder, hazel dormouse, water vole, and great crested newt, and I'll be using the adder map as an example to explain the method in the rest of this video. Onto the input data. To make these maps, we used all records from all species in the Bionet region of 100 meter grid square resolution or finer, held on the LERC Wales database as of April 2021, which was about 815,000 records. The habitat data we used was the Phase 1 Habitat Survey of Wales, which is based on field survey data and achieved near complete coverage of Wales and is a very widely used dataset. It's available on Llay and is the best complete coverage dataset we could access for this. The only limitation, of course, is that it's now quite old, having finished in 1998, and I'll talk about that limitation later on. I'll show how we assign habitats to records using the example area highlighted by the green rectangle in the middle of this map, which is just outside Rhythin in Denbighshire. So zooming into that area, we take the Phase 1 habitat map, then we overlay the records on top of it. So the red squares here are all grid references of records. As you can see, some have been recorded at finer resolution than others. The larger squares are 100 meter grid squares, the smaller ones are 10 meter grid squares, and there are a few tiny 1 meter squares which are almost too small to see at this scale. And then we simply assign each record the habitat class that occupies the largest share of its grid reference. So we have all of our records and we've assigned each one a habitat. Now we can measure associations between different species and habitats using something we call the encounter ratio. And to explain what that is, I first need to define a couple terms. The first is the visit, and we define this as any event where 1 or more records are made at a particular date and location. In this case, location is 100 meter grid square, and the Bionet region contains about 175,000 100 meter grid square visits throughout the region and throughout time. And we define an encounter as any visit with 1 or more records of the focal species, which in the case of this map is adder, and there are just over 1,000 adder encounters from the Bionet region. The reason that we group records into visits and encounters rather than just looking at the raw records is that it smooths out some of the idiosyncrasies that arise from a large database of records from lots of different sources. For example, in some case there'll be duplicate records where multiple people saw the same species at the same date and grid reference and they all recorded it. Or we might have got the same record many times from multiple different data sets from different sources, or lots of other examples. So this just standardizes things a bit. Now that we've defined visits and encounters, we can look at the encounter ratio, which for a given species habitat combination is the proportion of all focal species encounters that come from that habitat type to the proportion of all visits that come from that habitat type. For example, still thinking about adder, let's look at the habitat type dry acid heath. About 2% of all the visits in the Bionet region come from this habitat. That is, it's the dominant habitat in about 2% of all these 175,000 visits across the region across time. However, About 20% of adder encounters in the Bionet region come from this habitat. That's an encounter ratio of 20 to 2, or 10. The proportion of adder encounters coming from dry acid heath relative to the proportion of visits being made to that habitat is very high. We infer a strong positive association, and this suggests that areas of this habitat type have high potential for suitable adder habitat. As another example, let's take the phase 1 habitat type improved grassland. About 26% of all visits in the Bionet region come from this habitat, in large part because it occupies just over 50% of the area. So a lot of these will be visits where improved grassland occupied the largest share of the grid square, but in all probability the record was made from some other habitat type. Nonetheless, only 3% of all adder encounters in Bionet region come from this habitat. This is an encounter ratio of 3 to 26, or about 0.12. So the very low proportion of adder encounters coming from this habitat relative to the high proportion of visits coming from that habitat suggests a negative association, and that areas of improved grassland are unlikely to contain suitable adder habitat on average. I'll give one more example, this time looking at the association between improved grassland and carrion crow. In this case, I'm using data from all of Wales, as I haven't computed this one for Bionet specifically. About 28% of all the visits across Wales come from improved grassland habitat, and about 32% of carrion crow encounters in Wales come from that habitat. So the encounter ratio is 32 to 28, or about 1.1. So in this case, the proportion of the species encounters coming from the habitat and the proportion of all visits coming from the habitat are not too different, so their ratio is close to 1. And this is exactly what we would expect for a species that showed no strong positive or negative preference to a particular habitat type. In that case, we would expect the number of encounters coming from that habitat type to be roughly proportional to the total amount of recording going on in that habitat. So in this case, we infer no association or no particular preference. To summarize, encounter ratios provide a direct measure of association between a species and a habitat, and a rough measure of habitat suitability. We can view encounter ratios close to 1 as signaling no association or no habitat preference. Encounter ratios much greater than 1 as a positive association, implying suitable habitat, and encounter ratios much less than 1 as a negative association, implying unsuitable habitat. Now that we've explained these encounter ratios, we're ready to interpret this map. I've called this a habitat association map rather than a habitat suitability map because, as I said before, it provides only a rough guide to habitat suitability. The main reason for this is that encounter ratios are affected not only by species habitat preferences, but also by varying recorder effort between habitats. And we can think of this recorder effort as having two main components. One is the general recording activity. That's just, well, as you'd expect, the total amount of recording of all kinds of species going on in a habitat. And we are accounting for that by expressing these encounter ratios relative to the total number of visits. So you'd expect if recording activity in general is higher in one habitat than another, you'd expect to find more records of every type of species in that habitat on average. The other component of recorder effort is targeted effort for particular species, and this is much harder to account for and is one reason why we have to be careful with interpreting individual particular encounter ratios. I'm going to illustrate this point using this table displaying the top 10 habitats for adder by encounter ratio in the Bionet region. All of this data is for Bionet only. First, I'd like to draw your attention to the top 2 and 3 habitats, unimproved calcareous grassland and dry acid heath. We can see that unimproved calcareous grassland has a higher encounter ratio than dry acid heath, 13.5 to about 10.5, but it would be quite risky to conclude from that unimproved calcareous grassland is more likely to contain suitable adder habitat. We need to take these encounter ratios in context with the other information in this table. In particular, we can see that unimproved calcareous grassland occupies a much smaller proportion of the Bionet area than dry acid heath, which is much more extensive, and as such it's much more likely to be part of nature reserves or protected sites and therefore be subjected to more targeted monitoring, particularly for a priority species such as adder. And that's just one reason I can come up with off the top of my head to not trust the difference between these two habitats, and I'm sure people with local knowledge especially could think of many others. The general point here is that quantitative assessments between different habitat types for a species based on their encounter ratios is very difficult because there are so many other factors at play beside the species' habitat preferences that also affect the encounter ratio. However, qualitative assessments, that is, picking out which habitats are associated with adder records and therefore likely to contain suitable adder habitat based on encounter ratios, is a lot more reliable. Moving back to the map, it's with that principle in mind of qualitative rather than quantitative that I tried to be quite conservative when choosing these categories to symbolize the map, using a small number of quite broad categories. So any habitat type with an encounter ratio greater than 2, that is, the proportion of adder encounters coming from that habitat is at least twice as great as the proportion of all visits coming from that habitat, are highlighted in red. Any habitat type with an encounter ratio less than 0.2, that is, the proportion of adder records coming from those habitats are only a fifth of the proportion of all visits coming from those habitats, are highlighted in dark blue. And we have two broad categories which you could view as representing low to moderate and moderate to high association in between. By making these categories quite broad, I hope that I've minimized the chances of habitat types being in the wrong category due to some known or unknown bias in the data. Even if the rankings within the categories aren't entirely accurate, it would be quite hard to imagine a habitat having an encounter ratio of 2 or greater through adder through biased recording alone, without at least some degree of habitat suitability. I actually came up with these categories before I knew what the results were, and I did that to try and avoid introducing my own bias when choosing the categories. If I had seen the encounter ratios first, I might choose the different categories to highlight the ones I thought should be suitable habitat for adder. So that's why it's come out in this somewhat idiosyncratic way, where we don't have any entries for the 0.9 to 2 category, for adder at least. Moving back to the same table as before, another important thing to consider is the total number of visits that each habitat has received. This is important for two reasons. First, if a habitat just has a very low number of visits to it in general, it's hard to consider it well sampled. Secondly, and more importantly for our purposes, if a habitat has been sampled sufficiently few times, such that it constitutes a sufficiently small proportion of the total visits, then it's possible for it to have a high encounter ratio, even if it only contains one or a few adder records, because often the proportion of adder records that it contributes will be larger than the very small proportion of total visits it contributes. We can see that clearly here. The habitats raised bog and limestone pavement, each of them only have a single adder encounter, so they only constitute 0.1% of the total adder encounters. But because the proportion of the total visits they constitute is so much smaller 0.03 or 0.04%, if you divide this by this, you still get a higher encounter ratio, despite the fact that we've only had one adder encounter from that habitat. Now, with these two particular habitats, in this case, it's easy to imagine those being good habitat for adder, but often when doing this exercise in general, we come across habitats that aren't necessarily good habitats for the focal species, or they're obviously bad, but just happen to have had one or two encounters by chance, but still have a high encounter ratio because the habitat contributes a very low proportion of the total visits. So we need to come up with something to deal with these habitats with a very low number of total visits. I've handled this by introducing a total visit threshold of 500 visits. So you can see in the text here it says data deficient habitat types have received less than 500 recording visits across the region, and they're all showing in grey. Anything with less than 500 total visits we've decided is insufficiently sampled to draw conclusions from. I picked this threshold of 500 visits because across all the 4 species that we mapped, the frequency with which they occur in the database ranges between 2 and 6 encounters in every 1,000 visits. So I decided 500 visits gives a reasonable chance of encountering the focal species in a broad sense on average. Others may come up with a different threshold or choose not to use one. These habitat types that have been sampled a very low number of times actually have relatively little effect on the final outcome of the map, because the majority of the map is dominated by relatively few habitat classes which take up most of the area, and those have normally been visited a high number of times. So let's look at those classes now. This table shows the top 10 habitats by percent area of Bionet. These are the habitats that will really be driving the colour of the map. Collectively, they account for about 88% of the area of Bionet. We can see that improved grassland, the most dominant habitat that occupies 57% of the area of Bionet, contributes relatively few adder encounters relative to the very large number of times it's been sampled, and therefore has an encounter ratio that's very low of 0.1, which is why that's dark blue. Same for buildings, arable, intertidal mud and sand, and semi-improved neutral grassland. These habitats are all contributing the dark blue area in the map before. Many of the red areas in the map are coming from areas of bracken, which contributes a high proportion of adder records relative to how much has been sampled, and dry acid heath, which contributes a large number relative to how it's been sampled. Also contributing to the red area, perhaps surprisingly, is planted coniferous woodland, which, although it only makes up about 4% of the total visits, almost 9% of the adder encounters are coming from this habitat, an encounter ratio of 2.2. Other habitats not shown here that contribute to the red area include most of the bog habitats. Contributing to the turquoise areas on the map with a weak negative association with adder records are semi-natural broadleaf woodland and unimproved acid grassland. Again, these figures will be affected by lots of factors beside the species' habitat preferences. For example, maybe planted coniferous woodland has a high encounter ratio because it's often adjacent to heathland or has elements of recovering heathland within the matrix. Maybe unimproved acid grassland is lower than expected because it tends to be on exposed upland slopes, or perhaps there just hasn't been much targeted adder surveying in those areas. The key question to ask when looking at these charts and interpreting the map is whether we think any confounding factors beyond habitat preference might mean that the broad category of the encounter ratio is inaccurate rather than just the specific value. Like any information derived from biological records, these tables potentially say as much about the distribution of recording effort as they do about the ecology of a species. I personally think it's still useful and interesting information. If nothing else, it can make one stop and think, and might make one think about which areas or habitats are unlikely to have received systematic sampling effort for a species. We've provided these charts in the form of Excel spreadsheets for every species habitat combination as part of the package that's been sent to the Bionet LNP. So I'd encourage you to use these to interrogate the maps, filter them, sort them by whatever criteria you want, and see what you make of them. And there may be some interesting and surprising finds. Moving back to the map now for some final notes on interpretation. These maps highlight areas more or less likely to contain suitable habitat at a landscape scale. They're indicative, not definitive, and should be used in context with other information, such as the tables we've provided. And before any decision is made based on them, it should be checked against satellite maps due to the age of the underlying Phase 1 dataset. I'll also just note that we've provided the GIS layers for customization, so you can play around with those and categorize the encounter ratios as you see fit, or remove or add visit thresholds, or only display particular habitats, for example. Finally, I would just note that this is a pilot project. We hope that in its current form it can be useful, but at the very least we hope it can be a stepping stone to continuing to develop more useful products. Any feedback is very welcome. This is the most simple form of this mapping method we could use, and we'd be keen to see if any ideas to improve it. Any questions or comments, my email is below. Thank you for listening.